Hello student, today we are going to see chapter 9 NCERT example problem. It's from class 9 physics chapter 10. Okay, I am going to give full explanation how we can solve also. I am going to tell you. Okay, all the example I am going to discuss. First I will do with 10.1. So NCERT example number it's a 10.1. First example from chapter 10. It is a gravitation. Okay, so given data, mass of the earth is given. Mass of the earth is given 6 into 10 power 24 kg. Mass of the earth. Mass of the moon also is given. So whenever kg you are getting, that's representing as a mass. So mass of the moon also is given 7.4 into 10 power 22 kg. And distance between mass and mass of earth and the moon is going to be 3.86 into 10 power 5 kilometer. Okay. Now they asked what is the force between these two, force of attraction between these two masses. That's the question. It's a very simple question. Okay, so how I am going to do with calculation, I am going to tell you, I am going to teach you. Okay, for only this problem approximate calculation I am going to do, remaining everything actual calculation we are going to do. Okay, now force we are going to calculate. So we have mass 1 here, mass 2 here. The force of attraction between these two mass, that's the question. Okay, it is m1 mass, m2 mass, earth mass, moon mass. Okay, distance between these two is going to be d. I am going to apply the universal law of gravitation. F is equal to g times of mass of the earth, mass of the moon, m1 m2 divided by distance between these two square. Okay, this is universal law of gravitation. Okay, the next thing I have to check all the units in the MKS system. Meter, kilogram, second. Okay, so it is kilogram, kg, but it is kilometer. I should convert as a meter. That's the first thing I should do. Then only I can able to solve the problem. G is a constant which is not given in the problem. Okay, D is given. Distance between earth and moon is given 3.86 into 10 power 5 kilometer. 1 kilometer is how many meter? Is 10 power 3000 meter. So D is going to be 3.86 into 10 power 5 into 10 power 3 kilometer. Kilometer is converted as a meter. So finally 3.86 into 10 power plus 5 and 3. Together if you are adding that to 5 plus 3 will get 8 meter. So distance I got. What is G? G is a universal gravitation constant. Okay. So which is a constant value. Sometimes they will give in a question paper. Otherwise you should know this value 6.67 into 10 power minus 11. Okay. This is a gravitation constant. Newton meter square by kg, unit of this. Now we are going to calculate the problem. F is equal to G times of mass of the earth, mass of the moon divided by distance square. Okay, now G is how much? F is equal to G is how much? 6.67 into 10 power minus 11. Mass of earth is how much? 6 into 10 power 24. Okay, plus 24. And the mass of the moon 7.4 into 10 power plus 22. Okay, divided by distance square. Distance is how much? 3.86 into 10 power 8 whole square. This is what we have. First I am doing all the 10 power I am bringing separately. Okay, see how I am doing. F is equal to 6.67 into 6 into 7.4. So all the numbers, then all 10 power minus 11 plus 24 or plus 22. Base is same, power everything you can make it together. It is square time 3.86 into 3.86 into 10 power 8 into 10 power 8. This will get 16. Okay. Again F is equal to 6.67 into 6 into 7.4 divided by 3.86 into 3.86. From denominator this value I am taken as numerator. It's going to be 16 plus 16. Okay, 8 plus 8 16. It's 10 power minus 11 plus 24 plus 22. I'll get 10 power minus plus 16. From denominator this if you are taken as numerator minus 16 will get. Okay, so finally F is equal to 6.67 into 6 into 7.4 into 10 power minus 11 24 22. What I will get? Minus 11. These two addition I will get as the plus 46. 46 minus 11 what I will get? It's 35. Okay, so 10 power minus 60. Denominator 3.86 into 3.86. Now I am going to make it as a round number. 2 decimal is there, 2 decimal is there. 100 numerator and denominator you can multiple. Okay, so 667 8386, okay, into 6, denominator 2 decimal, numerator 1 decimal. So 100 you can multiple, 740 we will get, denominator 386 we will get, okay, because of this 2 decimal, 1 0 extra I am getting. So this thing will be plus 35 minus 16. So what is the answer? Plus 35 minus 16 I will get power as a 10 power plus 19. So 10 power plus 19. Okay, because of this 0, plus 1 will be there. Okay, remaining as it is 667 into 6 into 740 divided by 386 into 386. I want to tell you one thing. See, 350, 350, 700, 386, 386, this is going to be approximately 2 times. I am doing approximate calculation, not accurate calculation. You can do with the accurate calculation. When we are calculating this, so we have to get more than 700, we have 600. So 2 times will come. In case here 760 is there, means 2 times. It's less than that, 1.8 approximately like that. If you are multiplying this, 6 into 2, 12, 12 into 2, approximately will get the value of 2, okay. So this power will be 10 power 9, 10 power 20, okay. The answer, final answer, so force is equal to, approximately equal to 2.01 into 10 power plus 20, okay. It is a force, we can have Newton, okay. This is a first problem solution. Now I am going to do with the second problem. See 10.2 second problem. 10.2 NCERT example 10.2 second problem, it's a 10th chapter gravitation, okay. So now what is the data is given? The car is falling at the edge of the some mountain, initial velocity, falling initial velocity is 0, okay. So horizontally, vertically it is 0. The time taken to hit the ground 0.5 seconds. The question is asked, what is the final velocity? What is the average velocity? Other than first question, remaining everything is a very simple question. What is the total displacement? Okay, initial velocity is 0, time is 0.5, okay. A dropped object, initial velocity will be 0, it is dropped only, somewhat it's falling from the mountain, okay. Initial velocity is 0. Gravity will be positive for dropped velocity, dropped object, okay. So it is towards the gravitation, so it's going to be the positive, it's 9.8, sometime you can take it as 10 also. V is equal to u plus at. First question I am going to solve. Initial velocity is 0, v is equal to 0 plus a is 9.8, t is off, okay. 10 also you can take it, 9.8 also you can take it. According to the calculation you can take it the value, because which is make you to easier to calculate, you can take it that the value, okay. If you are taken opposite also no problem, they will give full mark, okay. I am getting 5 meter per second, because 10 by 2 5 of v is equal to u plus at, u is 0, a is 10, t is off 0.5. You can write as a off also, 0.5 you can write as a off also. First answer I get 5 meter per second. Second question, what is the second question? Velocity average, average velocity, initial velocity plus final velocity divided by 2. What is initial? 0. What is final? 5. What is divided by 2? I will get 2.5 meter per second. It's a average velocity, velocity average. Okay, now displacement is taken to fall down. Okay, we can take it any of the equation of motion. Okay, I am taken S is equal to ut plus half at square. Okay, why I am taken that? Because it's easy to calculate. S is equal to ut plus of a t square. U is 0, so S is equal to half times of a is how much? 9.8 or 10. So I am taken 10. T is how much? It is off 0.5. 0.5 instead of taking 0.5, if you are taken off, the calculation will be easy. This will be 5. 5 divided by 2, 2.5. 2.5 divided by 2, it is 1.25. So total displacement is going to be 1.25 meter. That's the total displacement. So actually in this problem, all the data we calculated. What is that? Velocity. Velocity is 5 meter per second. Average velocity 2.5 meter per second. Displacement is 1.25 meter. So everything I got. Now I am going to do with the 10.3, the second problem. Okay, 10.3. 10.3. It is thrown upwards vertically. The object is thrown upward means final velocity will be 0. Dropped means initial velocity will be 0. The displacement is covered 10 meter. Okay, initial velocity of the object we don't know. What is the object thrown velocity we don't know. The question is what is the initial velocity and what is the time taken? It is very simple question. Okay, you can take it any of the equation of motion which is you feel easy to calculate, that you can take it. Okay, we have 3 equations, any of the equation you can take it. I am taken initially, it is v square is equal to u square plus 2as. Why I am taken this equation? Because the gravity is upwards, g is minus 9.8 meter per second square, 10 also we can take it. Okay, final velocity is 0, final velocity is 0, u they are asking, 2 we know, a we know, s we know. Okay, so for calculation purpose only we are taken as a suitable equation. So first v square is equal to u square plus 2as. Final velocity is 0, initial velocity we don't know, 2, a is 9.8, displacement is 10. Okay, so 9.8, 10 also sometime you can take it, that already I told you. Okay, when we are multiplying this, so 9.8 into 2 will have, it is 19.6, this is going to be 19.6 into 10. Okay, it is minus u square is equal to 0. From left hand side, if you are bringing this as right hand side, 19.6 minus has become plus into 10 is equal to u square. So u is equal to root of this is going to be 196. Root of 196 answer will be so 14 into 14 only will get as a 196. Okay, this answer I'll get 14 meter per second. If other than this equation, other than this, if you are taken anything, means the data will be sometimes insufficient. Okay, so we are not able to calculate. Okay, the point is I am telling which the data, based on the data you can choose the equation. Next is the time. Okay, now you can take it any of the equation. Only first condition you need to substitute with the certain value. Otherwise, you can do whatever you want. Okay, v is equal to u plus 80, v is 0, u is 14. Gravity is minus negative. Why? Because it's going to be opposite to the gravity, 9.8 t. So 14 divided by 9.8 is equal to t. Why I am getting like that? This cross, this from left hand side to right hand side, if you are bringing 9.8 t is equal to 14. 9.8 if you are bringing as denominator, t is equal to 14 divided by 9.8. That's we will get 140 divided by 98. So approximately if you are cancelling 1 point something will get. Okay, 1.4 3 seconds actually, 1.4 also you can write, 1.43 also we can write. Okay, so if you want division, that also you can do 140 98, it's going to be 1 time, then remaining you can write it here, remaining will be 42, the data is not enough, 0.0, this going to be a 4 times approximately. So 1.4 if you found also, it's fine for this problem. Okay, now next problem I am going to do. So right now we are in 10.4. 10.4 is very easy. 10.4, the problem is 10.4, mass is given as 10 kg. Okay, weight is equal to how much? Weight is equal to F is equal to mg or F is equal to ma, W is equal to mg. Okay, same, weight is equal to force only, F is equal to mg. On the earth, g is going to be 9.8 meter per second square. Acceleration will be 9.8. Okay, always with the mass, if you are multiplying with 9.8, you will get weight. Mass is 10 kg, g is 9.8. Okay, so it is weight, no, force unit, Newton we can write. Otherwise we can do like this, Newton. Okay, it is kg, it is meter per second square, like that also you can write as the Newton. Sir, in case I am taken 9.8 instead of 9.8, 10 I am taken, what is the value I will get? Approximately 100 Newton I will get. This also correct. Okay, for small problem you can take it the value as a 9.8. When you are not able to do the calculation with 9.8, that is the time you can go with the 10. That's the for technique you can use it. Okay, if you are feel using of 9.8, the calculation will be very big, means you can use it as a 10. Okay, now next 10.5 problem. It is NCERT example problem 10.5 class 9 physics. Okay, weight on the earth surface is 10 Newton. They asked weight on the moon surface. Okay, mass on the earth and mass on the moon will be the same. Okay, the gravity on the earth surface, it's going to be 6 times of gravity on the moon surface. That's the difference. Okay, the same difference we can maintain, weight on the earth surface is 6 times of weight on the moon surface. Mass is constant. Okay, so mass, gravity on earth surface, 6 times of mass, gravity on the moon surface. Okay, So now I got weight on the earth surface. This value I got, okay. So weight on the earth surface is equal to 6 times of weight on the moon surface. Whatever present weight on the moon surface is 6 times of weight on the earth surface. If you want what is moon surface, divided by 6. Weight on the earth surface divided by 6. I know this value, it's 10 divided by 6, okay. If you are doing 10 divided by 6, it's going to be 6 one time, 4.0, it is 36, okay. So next also 4 will go, 6 bar will go, okay. So weight on the moon surface, it's 1.666 bar Newton, because it is a weight and force unit will be Newton, okay. So weight on the moon surface we can write as a 1.67 Newton also, okay. Now it is, now I am going with 10.6 problem. Next problem from gravitation, just a minute. 10.6. Okay, they are given block, okay. So it's NCERT example problem 10.6 physics class 9, okay. It is a pressure problem. We have the block, okay, two sides of the block they kept. Initially will be like this, okay. Mass of the block, it is a rectangular block 5 kg. Okay, the area on the surface, okay, surface on the ground, it's going to be 20 into 10, okay, 20 centimeter, 10 centimeter. They want what is the pressure on it, okay. The next one, the block they kept in another side, okay, the same rectangular box they kept as another side, okay, this side they kept. Now it is 10 into 40 centimeter, okay. Here also they want pressure, okay. For both the case they want pressure. It's this problem also, it's very easy problem. First I am going to calculate pressure. Pressure is equal to force per unit area, okay. For first case 1 will do. Case 1, pressure is equal to force per unit area. Force is how much? mg divided by A. Area is length into breadth. Length is how much? 10. Breadth is how much? 20. So m here it is 5. G here 9.8. Length is how much? 10. Breadth is how much? 20. It is centimeter. You should convert as a meter. 1 centimeter is how many meter? 10 power minus 2 into 10 power minus 2. If you want to convert centimeter to meter, always you can do 10 power minus 2 multiplication, or you can divide by 100. Both is same only. You can do that one, okay. So it is going to be 2 times. Just a cancellation. So minus 2 will have 10 power minus 4. Minus 4 from denominator, if you are taken as numerator, will have plus 4. So 10 power plus 4. Again 2 table cancellation, I will get 4. It is going to be, I think 9. Okay, 4.9. Again if you are cancelling with 2 table, it's going to be 2, it's going to be 4, and one more 10 will come, then you will have 5. Okay. From denominator, this value if you are taken as numerator, 10 power plus 4 will come numerator. So 2.45, just a cancellation, division, divided by 10, okay. Now how I am going to do with the calculation? See here, pressure is equal to 2.45 into 10 power 4, I can write 10,000 divided by 10, cancel. This 2 multiplication 2450. Because of this 2 decimal, 2 zeros will go, okay. So finally I will get pressure. Newton per meter square also you can write, because force per unit area. Or you can write as a pascals also. Whatever unit you like it, you can do it, okay. If you know pressure unit pascal, easily you can write. Okay, next question. The same, second half. So now the area is on the surface is going to be 40 centimeter, 10 centimeter. Pressure is equal to force per unit area. Force is how much? Mass into gravity. Mass is how much here? Mass is 5. Gravity is how much? 9.8. Area is going to be 10 into 10 power minus 2, 40 into 10 power minus 2. That's it. Now this is going to be 2 times. Same cancellation, okay. Minus 2 will have minus 4. I am taken as numerator. So pressure is equal to 9.8 divided by 2 into 40. So this I am taken as numerator, 10 power plus 4 we have. Next I am going to cancel. So 2 table cancellation 4.9 I will get. Again 2 table cancellation I will get as the already we did. So I will do here pressure is equal to 4.9 into 10 power 4 divided by 2 cancel we have 40. Okay, because of 1 power I can reduce, it will become 10 power 3. Okay, 2 tables if you are cancelling I'll get as 2.450. Okay, again 2.450 into 1000 divided by 2. So this I will get as 2450 divided by 2. 1 time, 2 time, 2 time, 5 times. Okay. For second case I will do again. Okay, 40 into 10. Okay, I am taking example 40 into 10. Force is equal to mg divided by a. M is how much? 5. G is how much? 9.8. A is how much? 10 into 40. Okay, so both is in a centimeter, you can convert into meter. 10 power minus 2, 10 power minus 2. This is going to be 2 times. Okay, if you are cancelling this into this, I will get as a 4.9. Okay, so from denominator if you are taken as a minus 2 minus 4 as numerator, 10 power plus 4 will come. Okay, again denominator we have 40, 1 0 will get cancelled. If you are, when you are cancelling this 2.450, again if you are cancelling with 0, 1.225 will get. Okay, into 10 power 3, because this 0 power will go. Okay, so 1225, because this number into 1000 will get like this much Newton by meter square pressure. Okay, third case I will do. For example, I will do with all the cases, 2 cases. Okay, already we did. The third case I am taken as the area as 20 into 40. 20 into 40. Okay, centimeter. Now what is the pressure? Pressure is equal to force per unit area. Force is how much? 5 into mg. 5 into 4, it is 9.8. Area is how much? 20 into 40 into 10 power minus 2 into 10 power minus 2. This you can take it as numerator. 10 power plus 2 will come in the, plus 4 will come in the numerator. So this will become as 4 times. Okay, so 9.8 divided by 4 into 4, we can have 2 into 2 into 2 into 2, because 4 I am writing 4 into 4, 8 I am writing like this, into 10 into 10 power plus 4. Reason this I am taken as numerator 10 power plus 4, because of this 0 I wrote here 10, because of 4 into 4, 8 I wrote like this. First time cancel, we will get as 4.9. Second time cancel, I will get 2.250. Next time I cancelled 1.125 I will get. If I cancel with next time, so that I will do in a separate page. Okay, what we have, the just 4 times we should cancel with 2 table. 1.125 divided by 2 into 10 power plus 4 divided by 10. So 1 power will go, 10 power 3 will be there. Okay, this is going to be 0.6. So if you are making as a round number. Okay, zero 0.6 125 like that we'll get. If you are multiplying with 1000, we'll get as a 612.5 pascals. Okay, I hope you understand how to do this calculation. Then finally we have the last problem, density of the substance. Okay, silver. Okay, 10.7. Okay, it's 7th problem from 10th chapter. Example 7. It is from 10th chapter, gravitation, class 9 physics. Okay. So relative density is equal to density of the substance by density of the water. Here relative density of the silver is given. Relative density of the silver 10.8 is given. This is given. Water is 1000. Okay. Now density of the silver, they asked. Density of the silver is equal to relative density into density of the water. Relative density is how much? 10.8. Density of the water is 1000. Instead of writing 1000, you can write 10 power 3 also. 10.8 into 10 power 3. What is a unit of it? It is a density. Density is mass per unit volume. So kg divided by meter cube you can write, or kg meter minus 3 also we can write. It is a 10.7 problem. Okay, that's it. We completed all the example problem from chapter 10. It is a gravitation and pressure. Both the problem we calculated. Thank you everyone.